The old man built. The old man built. The old man built. The old man built. The old man builds is broken in the head. People not seeing reality has put them in the red. Where conscious and spirituality been stricken from the norm and replaced with the ignorance of basic magnetic form. The geometry of God keeps running through his head. That's what makes old man builds broken in the head. The old man builds. The old man builds. Spheres of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to extend. The old man builds. The old man builds. The old man builds. The old man builds.
What's going on, everybody? Hopefully everybody's having a great day, man. I'm actually doing better myself. Went and got over my cold. Getting able to, go walking without hacking up a lung again. So, pretty good, man. Pretty good. Got some experimentation done over the weekend. Some cool stuff, man. That neutron Tesla coil is awesome. And we put some high voltage into it. Not a lot. It was, it was about 30 volts. It wasn't very much. And we got the thing to fire off, man. And it made this kind of a fiery lightning bolt. So I'm pretty happy about that. I got to find 2 more diodes so I can put it in AC. And then we'll pull out the variac and we'll let it rip. I would expect that these things out of each side is going to be 6 to 8 inches long when I do it in AC. So the tuning on it's gone great. The cap bank works beautiful on this thing. Not a problem whatsoever. Tunes in right away. Couple clips, man, and it's already in tune. Got a good amplitude to it. So we shouldn't have any problem going into AC with this thing. So I'm pretty excited about that. Then we'll put it through some more tests. We already got it rotating. We got some nice fiery sparks out of it. That's all DC. We'll go into AC, man, and really start ripping it. So, see, you know what I mean? Get all the other tests out of the way before we start doing it. I'm almost done rebuilding my whole studio here. That's why you see stuff everywhere behind me. Trying to make room. I redid my printer section so I can hang up all the Spider-Man stuff behind it and some Batman stuff behind it, and painted everything black. So it looked gorgeous over there. So here, I'll see if you can't take a look at it. Yeah, we got it all cleaned up over there. It's all black now. All over there in the big toolbox, man. We got everything rocking and rolling over there so we can start doing our prints and I can start printing stuff off again. So I'm excited about that, man. We got that going. That we had thank you. Yeah, we did a lot of stuff, man, with the RAV over the weekend. We got together, Sean, myself, and Joe, and decided we're just going to write a actual paper on it, and used all the fancy words. And I'll let them write space time on the paper. But yeah, it's gonna come out good, man. We'll get that out, and then we'll start showing the rest of it. I think it was kind of a wake up call this last week, man. We got to get away from what the camera's showing and get to what the results are in the speeds that it's showing, in the temperature differential it's showing, stuff like that. All that's going into the paper. We will not put the artifacts from the camera in there at all. I'm not going to argue that point with anybody ever again. That's useless, and I won't do it. So we'll just do the simple facts of it and put in all the material. We have microscopes, so we'll be looking at the material in depth. It's cavernous inside. It's kind of cool. So it's going to be a different thing to look at. I'm excited for that, man. So just something we'll start to do. I have a lot of coil stuff coming up. I ordered wire, it's coming in, and I set up my desk area. So off to my side over here, I have my desk, and it's got the, I don't say a big old monitor on it, but I took my GoPro and I aimed it straight down. So you guys know when I do all the wiring and stuff, and we're building cat banks, and the camera angle just sucks. And it has for a while. And the best way to do it is to shoot straight down. So I got that set up, and we're going to be doing that, man. So I'm going to be winding coils, and I have to wind another rodent coil, and then I'm going to start winding geometry coils. So what I'm going to do is I'll put out the list of which piece I'm going to, and then we'll wrap it, and then we'll take a standard circuit like a jewel thief and put it on the coil and see what it does. At that point, you'll have everything. You can wind your own. Good, bad, and different. Some are going to come out good. Some are going to come out bad. Some are going to come out bad frequencies altogether, and we'll have to just deal with it. You know what I mean? But we'll go as we can and just go stick with all the geometrical patterns that we're used to. Make sure we get all those in there. But I think that'll be pretty cool, man. Pretty authentic experience. Most of that winding of the coils will be on my second channel. And then I have another channel for 3D printing that we're going to do. I'm going to go through all the CAD work that I do to set this stuff up. So I'll link them all for the shows on Monday, Wednesday, and Friday for the lives. I'll just link all three channels on there. But we'll do individual projects for each one of them. And I'll show you how the CAD works and the 3D printing works. We're on a couple old CR10s, so we're not going to go crazy on the printing, to have something special. But we are just going to use the CAD mostly and show you how to build things from the ground up. Especially all the coils, like all the geometry coils, the quick tricks we can use, stuff like that. That's going to be awesome for people. So I'm just setting everything up, you know what I mean, so we can get cameras on printers. I'm setting up my RAV station so that can be set up permanently. I never have to take anything down, and I have a clear board where I can start doing my videos again. I haven't been able to get over there to make any videos on the whiteboard lately. So that will change because now I'll have the room again. I must have gotten rid of thousands of dollars worth of machinery out of my garage here that were left over from cabinet making and stuff like that, just so I can clear the way for this thing to be rebuilt the right way. So yeah, it's getting better in here. It doesn't look like it from the junk behind me. Trust me, I know that. But the other side is getting better. Now we're doing. I ordered some laser stuff, things about this big, so I can just look in there and see it while it's running. But if I have it on camera, what's even better is if we have it on camera, and I found a couple of old cell phones to use, stuff like that, I could just record it and put it on the monitor right away and record it right off of there. And I think that's probably the better way to go because I do want a little bit of distance, and I have a Geiger counter on order to make sure I'm not picking up any gamma in the room. So with those things said, man, I think coming in the next few months, man, we're going to start hitting some things heavy. My health's been a lot better, so yeah, it's kind of turning around. So a lot of projects I wanted to get to, I'm finally able to get to. So, and that was including that last geometry coil I did. I've been kind of lagging on it because I've been painting and cleaning things up, and God knows I'm not 19 anymore, man. I can't get out here and bust it out in the weekend. It just doesn't work that way for me anymore. But it looks good. It came together for what I can do at this age. And yeah, we'll start doing the show from the other side of the garage, man. Do all my camera setups. And what I did was hook things to the wall instead of tripods everywhere so I can just pull them down and stuff like that. Some convenience. So I can set cameras quickly and get it going. So yeah, safety first, man. Yeah. That's never been the rule around here, but it's going to be. You're absolutely right. 4 days of pain. Yeah, it's been like a month of pain. Let me tell you that. It really has. Every time I go to do something, man, my back flares up, and It's like it feels like it's an inch thicker. You know what I mean? Right at the bottom there, where I had surgery. God, it's terrible. Getting around with that sucks. But we got a lot of things going, man. A lot of cool things. I'm gonna throw some sales on my Tesla coils here soon. If you're waiting for to get one to see if it goes cheaper, I will be putting a sale on them here this weekend, or excuse me, this week after today. So check it out, man. It's on my Esty store. I put in the link in the description. It's also at the top of the chat. We're going to be doing it through there. So hopefully everybody who wants something like that can get it. So, yeah, I got a 14-inch zipper on my back from when they cut it open. Yeah, I definitely got a scar there, John. Yeah. So let's see what we got here. I want to show you guys something. You've probably already seen it. Yeah, I feel so much better. Friday I was dying. Tesla coil here. I'm going to see if I can't get it to spark between this anode and cathode connected to each side of the coil. Look at that. That is just beautiful. I got my Yeah, you can see it, man. It's in this one's in DC. So we haven't hit AC yet. And it's only at 25 volts. So it's got a lot more in it. Oh yeah, it's got a lot of amps in it. I'm not fooling anybody, man. It's got a lot of amps in this thing. Like I said, it's only at 24 volts. We could go to 40 or 50. I got my bipolar Tesla coil here. I'm going to see if I can't get it to spark between this anode and cathode connected to each side of the coil. Look at that. That is just beautiful. So I have another one. Let me find it. Oh, someone was asking if I could make a RAV out of it. Take a look at this. That's my Tesla coil. There's my RAV. Bipolar Tesla coil will absolutely create a RAV. Awesome. Why does it go up the arc? Well, it would normally spark across normally, but there's so much amperage in there that it thickens the plasma. So, and then it just goes up like fire. Yeah, check that out, man. I used a bipolar Tesla coil to create a RAV. It's just awesome. Yeah, this stuff's pretty cool, man. I told you guys it's all the same drivers, it's all the same thing. Kind of proves it. This thing turns on the light bulb still too while it's making the RAV with the coil. So the coil's putting out some juice, man. Yeah, well, it's lower power because I turned it down. I mean, we're running about 15 volts right here. I could crank it up and get some big arcage in there, but I didn't. So yeah, we got cool stuff going on, man. Yeah, when you take these things and you realize what all of them really are, I mean, it gets pretty simple. We're still using the same ZVS, using the same cap bank, same power source. We just changed the coil. Yeah, it's you can see in the center part right there, there's that plastic piece, and you'll see those little white wires hanging out of it. That's your number one coil wrapped inside there. So it just keeps pacing in the center of this thing, and it's equally balanced on both sides. Um, it's hollow in the center, so you got to remember it's 5 millimeters high on each one of the little what do I call them, little arches or whatever you want to say. The depth of them is about 5 millimeters, so it's very small. And then you fill it with wire on each one of them, and you start at one end at the small end, go all the way up, all the way back over, so it's one winding all the way through, and then you put the secondary on there. Now this one, I had to take that wood dowel and thread it in there because I put threadings on both sides so I could put bolts on it and do some high arcing on it. But that's why that wood's in there. It's threaded in there, so I can pull it out at any time. But I had to thread it in there and get it so that I didn't blow stuff up all the time when I turn this thing on. Yeah, the grooves. There you go. Ian's got it. Yeah, it's regular bipolar. Yeah, regular bipolar Tesla coil. I know. I had somebody try to tell me, no, no, it's not Tesla coil because I mean, different shape or whatever. It doesn't matter. They're all the same thing. Bipolar means you don't need grounding on one side of it, and both sides are active, is what's going on. In This means that it has a north and south on it. Depending on how far the primary goes to one side or the other, there's a north and south created. That's why a standard Tesla coil is a monopole, because the number one winding goes all the way down to the bottom of the number two winding. Therefore, it only creates one direction. Doesn't have both. This has both. So there's a difference in the two types of coils. This is bipolar, and Tesla had plenty of those. He built those in his patents and told you exactly what they were. The Odin coil, when they built it, was a single pole, and you could put the little magnet tester on there, and it'll tell you the same thing. It only reads north, does not read south ever. When you get a secondary coil going somewhere else, even if it's wired directly in, that will read a north and a south, and will have a null zone in it. So, especially if you put a secondary coil inside of that secondary coil, then it'll really have a null zone in the center. Yeah, it's kind of a flyback in a way. Absolutely, like an AC flyback. It is kind of what it is. So you can do in Tesla style, where it's a continuous wind, one on one right next to the other all the way down. You could do it in AC flyback style, or multiple windings on the same one, and then you go to the next one, and then you go to the next one. And Sean does his coils like that when he does the straight coils, and they're multi-layered and stuff like that, and they get a lot more compression in them, and they do a lot more energy through them. There's in the coils that I build, just so you know, the number one winding goes all the way down. So if you're saying you have a coil, but you left this much of the bottom open, then yes, it would be considered two poles. I do not leave that open on mine whatsoever. That is gone. So, like I said, my number one winding on mine, all the way down to the very bottom. Okay. All the way down, bottom layer. If you have this much, it comes off the bottom and you wrap it, you will have a second pole under it, unless you get the number one winding all the way to the bottom. I build mine a little bit different than when you go and build them, just put 2-wire wrappings around it, and that'll change the actual configuration. So, just so you understand that. Null zones, yes. So when you put the light on there, it'll go null, or the light will turn off. And it doesn't mean that it has no energy. As a matter of fact, it's the exact opposite. What it means is it's carrying a vortex from the top and one from the bottom, and the saturation between the two holds in the energy to that zone and doesn't let it out. So it's not actually null of energy, it's full of energy. It's just something that's not going to excite the gas in the tube. So it is magnetic wire, and you cannot run this coil without putting the resin over top. It'll burn up, and I've done that on several coils. I have not put the rod in the center on this one. I did, however, set it up where, let's see, it has threaded inserts on both sides. So I can put in a bolt in there, a 1/4-inch bolt, as deep as I want to go for each side. But because it's bipolar, I can't put it all the way through because it'll start sparking internally. So I can put it in a little bit of a depth in there, and I can still get, about 1.5 to 2 inches in there. So I could probably pull off the 1-wire energy out of it. I just have to be, respectful of the fact that the other side is also hot. So you can't put it in too far. Your question, you just use the enamel. So, yeah, the enameled magnet wire. Yes, that's what it's called, just enameled wire. So usually it'll tell you, hey, this is magnet wire. If you put it in, especially if you go on Amazon, I always type in magnet wire. Same thing when I go on eBay or something like that. And they'll tell you it's for building transformers. That's all you'll know. You don't want something that's for hanging wall art. You want something that's for building transformers. And Remington is one of the companies that's out there. There's 2 other real good companies that do the wire in there. Usually Amazon is where I buy it. They're pretty good about delivery, pretty fast. And the prices are about the same as everybody else's. And then epoxies, if you multi-layer any winding. You don't have to do it if you wind one after the next, after the next, after the next. You could just spray that with clear. But if you're going to combine the height of the wire, one after the one after one like this, then you need to epoxy it together. It's because you'll melt the actual shielding on the wire, and then they'll start sparking to each other and ruin the whole thing. Nice. Yeah, enameled copper. Yep. What's going on, His Highness? Hmm. Yeah, mineral oil has definitely reduced a lot of the stuff. We're not looking for that necessarily what we're doing here. But yeah, mineral oil is hard to get through. Electricity does not like to flow through mineral oil. I can tell you that right now, no matter what kind it is. So that's absolutely true. Nice. I want to say this. It just keeps it cooler. And I don't know of a better way to describe that to you. When you put the resin in there when they're multi-layered, one above the other, The resin obviously penetrates in there more, and it basically puts a wrapping around the wire as a stronger deterrent for the heat to get through, but it just makes it cooler. And that's really what it is. As long as you don't go stupid crazy on these things and melt them down, you're good to go with that. It's like putting in a mineral oil. You could put it in mineral oil instead. It'll have the same effect. It gets in between all the different wires. But epoxy is much better because then you can move your coil around without having a big tub of mineral oil following it. So, right on, brother. Yeah, the epoxy, it was actually really easy. A couple things I did learn when doing it though. Keep about half of a cup. So you get these little cups about this size, okay, about this big around. And for a coil like this, you normally it's half and half, right? So I just dropped the cup maybe this far down on it. Okay. So I took about 3/4 of it, filled it with half and half, poured them together, mixed it up. Okay. Good to go. You can hit it with whatever the coloring you want to in there, and that'll give you enough. Now you want to keep half a cup back, and here's why. It takes 1 hour to get through the process of it to harden to the correct hardness. So at about 3/4 of the time through, you want the second amount to go on. And that's when the first set's starting to harden and the second set will go on. It would be even better to mix the second part a little more hardener so it goes a little faster on the dry time. That would even help. And because it's the way the geometry goes, the epoxy actually flows up to the center all the time. So you cannot have this thing speeding through there. It has to be the absolute slowest before it stops. That's the speed you want. And if you could do that, man, then it basically stays on there and you're pretty good. You go it any faster and you're going to have a ton of it build up in the center and it's going to be an absolute disaster. So, not too bad. On a regular coil like this, not bad at all. It'll go on there, stay, keep it, once you get it on there, put it on real slow. Just put it on real slow, let it sit for about an hour, harden up, it'd be great for you. Not a problem on that, man. I was really worried about first time doing it, and it turned out fairly easy. Just tap it in. Just tappy tappy. Huh. Oh, nice. John's working on battery plates. That's cool. Right on, man. Right on. Yeah, I can't wait to start winding coils again, man. It's going to be a fun time. I do enjoy doing it, and we'll just have to get a board and stick them to the board so they stay there while I do it. I did come up with a different way to do it than everybody else, though, and it is quite simply something I don't like using screws or nails. And the screws themselves, they start cutting into the wire on the shielding. Didn't like it. Putting straws over it didn't help. Putting in nails, you still got to pull the nails. And then once you do, the actual coil itself goes in and there's no tension there. And those suck. Okay. So what I did was I built this ring, 24 slot ring, and then it gets wooden dowels put in it like this. Now it has a second ring that goes over top. So what you do is you put it in there, you put the ring below it to first start it. Okay. Then you can wind all day long, cut these down to the right height. Okay. Start winding. This is the pattern that I'm going to use for the first one. I generally put the pattern on there. And on the outside, I'll put another wheel out there that shows the number of it. Okay. As I go through. And then I'll just wind it. So that way, when I'm done, if I decide, hey, I just want to compress the outside, I can compress it without losing the tension from this side to this side. So that's kind of one of those things that works out. You're always welcome to use a nylon bolt and put a little sleeve that goes over it if you want and get real specific in it. For me, wood is the non-conductive part. We're in low energy, not going to burn the wood. It's going to keep us right in that balance of keeping the tension on it. We can compress both sides of it. Okay. And that's what we're looking for here. So geometry coils should come out really good. Every time I built them on pegboard, I absolutely hated it because you had to take them off of there and then they get loose and they don't work the same. So I want to keep it in the structure at all times to keep the tension on it because I don't want to put a bunch of glue on there from a glue gun. I don't want it to look like I jerked it to the coil and it's all over the place, man. That's not what I want. That's ugly looking. Not trying to epoxy these things every 5 minutes. You know what I mean? I simply just want it built and I want it done so I can do it all one day and have it ready and start testing because that's where the money's made. You got to get it into testing. So, and like I said, these things are relatively low energy that runs through them. The center of the coil, when we get to it right here, that's where the energy is going to be. If we build it right, that's where the energy is. Okay, and that's what I want. So I have two circuits. We have a modified Joule Thief from Ben, and Gerald also gave us his over Unity circuit. So, or his backwards NPN circuit, I should call it. So we're going to use both of those to start off with, and we're going to use cap banks to balance them so that we can get both sides to read equal. And then we'll see if we got any kind of effect for over Unity. We'll test the center. We'll build some ferrite cores and wrap them and see if we can't pull them out of there. That's how we're going to pull the energy out of the center. And then once we get into it a little bit, I want to start taking a cup of water and put it in the center, things like that. I want to see if it's transmutating and everything. If I'm right and it amplifies the energy in the center, we may be creating an ether in there. And if we do, the first thing we want to do is take some orange slice or orange peel, kind of rub the cup with it, and then put the water in there, see if we get some transmutation going on. So that's the whole reason you build these coils, man. You don't build them to hang them on your wall. What happened to Brandon? Brandon's been working, from what I've seen on Facebook, he's been working on his little house he was building because he sold it and he's got to finish it. So that's what I've seen of Brandon doing lately. He puts up quite a few videos on Facebook if you're on there. Let's see what we got going on here. Nice. Yeah, sorry, I'm reading everything. Yeah, I've seen Brandon's doing all right, man. He's just building out that cool looking little house thing he built. So it's all geometry angles on it. That thing's pretty awesome. So yeah, widen those coils will be awesome, man. Like we're gonna probably see if Ben's available to come on the show, and we'll do the Rodin coil with him if he wants. If not, I'll just build the circuits myself. So I believe I have all the parts. I've been collecting them for that. And then eventually down the road, probably 4 or 5 months, we're going to get into pulse motors and Bedini. I plan before next year's up to have every single type of coil built and every pulse motor built. So if you're into any of those things, man, I want to build them all. I have found a very specific area where everything operates, and I'm going to take advantage of it and run every single system through it until we find out what every single one of these things does. So if you're into that kind of thing, man, it's going to be off to the races here in the next month. We're going to just start rocking this stuff out. I have no more patience for anyone else. I'll be honest with you. Just tired of waiting to see the next progress. I'm just going to do it myself. And we're just going to keep going, man. We're going to run until we find all of it. So, yeah, I don't plan on waiting. Nice yarn winder. Pretty sweet, man. I seen one of them automatic winders there that they had on the YouTube. I don't know if you ever seen them for the geometry coil winding. I think those things are sweet, man. I would love to be able to build one of those and do it, but I would probably need some technical help on the programming of it. So it's the same thing with the Tesla coil one, man. I got it great. I need to get a good tensioner where I put the sprockets in. You know what I mean? Like 1, 2, 3, 4, and let it wind like this. So that it has tension at all times, come out to a little piece, and then go right to it. So it stays tension. That's one of the biggest things on this, but without pulling the wire and thinning it. And then I can wind coils way faster. So yeah, and I could bring down the price of them if I can get them done faster. So yeah, it takes some technique to get some of this stuff done because you got to get into the Arduino, get into programming. They have some set programs, but you got to learn what the language is to do it. I took several classes on it a long time ago, man, but I'm nowhere proficient at that stuff. You're perfecting STL files. I do that myself. Nice. Yeah, I've gotten to the point, man, where about 45 minutes into Fusion 360, and I can create very complex structures. So I whipped through that sucker fairly fast. So I sit there and have my coffee and jam the music and just start building. So yeah, I like building the STL files in Fusion. It's so much better. So easy once you get to learn it, but it takes a long time to learn. So yeah, we'll get into a lot of that here real soon. So oh man, we got some more other coils to build too, some Tesla coils. So we'll have to build the ones that are spaced out, and they're just totally different than the other kind we got. And I've decided instead of stacking the windings like I was going to, I really don't like that. I'd rather do an inside winding and then an outside winding. I think those are so much better. It's an old school Tesla coil. The distance between the windings are like this, and you use the wrapped wire. So it'll be different. So let's see. Nice. Yeah, Fusion's a good program, man. I'm happy they put it out for us to use for free. So I got to upgrade my computers to Windows 11 before October because they keep putting out that thing. So I'm sure you already know that. I'm not looking forward to going to the next Windows, man. They always have glitches in the beginning. Why a company would do this like this I have no idea. So yeah, that's what's kind of going on, man. That's what we're doing. So we're building a lot, man. Yeah, I haven't heard anything great about Windows 11 yet. I really haven't. I've heard a lot of bugs, man. A lot of problems with your SSD. Um, they just haven't worked everything out yet. Their switch, by the way, when they first started Windows 11, screwed up one of my GPUs and cost me some money. That really pissed me off, man. They screwed up one of the files, and then I went around, and it was not an NVIDIA one. It was the other one. And as soon as it was like an AMD one. So they screwed up the file, and then at the company there, the download file was screwed up. So it would basically raise the temperature on your GPU and screw you up. They wanted you to upgrade. They did it on purpose. They screwed us over. So I had one that was working just fine to run a computer. And then all of a sudden, man, just out of the blue, ever since they started programming stuff different, it ruined the entire thing. Complete bunch of a-holes, man. Never forgot that. Never buy their card again. Okay. I just won't do it. Not if you're going to pull stuff like that, dude. That was dirty and low and cost me money. I hate companies that do that crap. It will come with AI. Oh, great. More more people telling me what to do. Huh. People are still using Windows 7. Well, Windows 7 is not going to work for my Fusion 360, unfortunately. I may have to run the Fusion on that other computer I have sitting over here, just for that reason. Yeah, yeah, it was unethical, wasn't it? It was dirty. They ruined those GPUs, man. Every single one of them started heating up after they did that. And every time they said they put out a fix, they didn't. If you had an old driver and you reinstalled the old driver, it worked just fine. It was their driver. It was 100% on them. Okay, 100% on them. The old driver worked perfect. Anytime you put in one of the new drivers, think card would immediately heat up. And you would think, oh my God, do I need to change the thermal paste in this, heat pads, anything like that? No, it wasn't it at all. These dirty jerks went in there and changed the programs of it and said, oh, they won't notice. Yeah, dirty creeps. Never forget that. Like we play with these things all the time, man. Take them in and out of computers. You don't think we notice the difference? I I usually have MSI afterburner on it, right? So I don't overclock anything or anything like that. But it's frustrating when you got to go in there and turn the fans onto this thing all the time, or if you go in and set it in the main setting on your card, and then it automatically pulls it out, like it won't stick in there and stay. God, it's frustrating. You'll be in the middle of something, and then all of a sudden it starts crapping out on you. Yeah, useless, completely useless. So yeah, it switches all the time. Yeah, I very much distasteful towards those type of things. So I before I got into doing this, man, I was building out computers for people, hooking them up. You know what I mean? Putting in whatever they wanted in them, make sure they have plenty of memory space in there, make sure they get it as fast as humanly possible. Things like that, man. People come to me all the time just to install their GPU in their computer. And after a while, it just wasn't worth it. It just wasn't worth it. You know, you get in there and something be failing all the time, and you just upgraded their stuff, but then the company decided, you know what I mean? Oh, that's not good enough anymore. So we're gonna. It's not just not support it; they went in and intentionally destroyed your stuff. Hmm. Huh. Google's messing with you. Yeah, they do it to me all the time. Do it to me all the time. Misspelling. Huh. Yeah, it does it all the time, and they do it. My computer runs just fine until an update comes along, and then my stuff starts messing up on me. Only then do we have problems. And I just wish, come out with an operating system and leave it alone. Just leave it alone. Stop screwing with it. You know what I mean? They're like little kids, man. Oh, I gotta touch this. 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 It's like, for God's sake, keep your hands to yourself. And you know what? I hate this digital licensing crap. I remember the old days, man. You go into the store, you buy the product, and it's yours. That's what I want. I don't want, oh, you're borrowing it. Oh, you can't do anything because you're borrowing it. I fucking hate that shit. God, it's so frustrating dealing with these people. Miss the old days, man. Yeah, security holes. They still haven't fixed that. Yeah. They just continue to give the government everything they want. If I were you, I'd never put it on your computer if you didn't want the government having it, because they get it all. That's what they're busy doing, selling your data, selling your information to the rest of the world. They all do it. They all say they don't. They all do it. They all make extra money doing it. It's ridiculous. Hmm. Yeah. Flywheel levitation. Well, yeah. Love to see it, man. Yeah, sorry. Just bitching about it for a little bit. Yeah, it did look like a plasma fame, didn't it? Yeah, it almost maybe not. The other ones where you put that little cup of, what is it, carbon or something on the top and it sparks off like crazy. Yeah, I gotta build one of those, man. I gotta create something that puts this thing in rotation at all times for any coil you do. So like a separate power source. We get these little batteries that they have for like little RC cars, and you can use those for your Tesla coil. Now I'll just take the standard Tesla coil and see if I can't create two plates, man, and just run this sucker in circles. I don't think too many people do that, man. They don't think about it that way. But if you separate the power source on this thing and you have it tuned, like it's not that hard. You can just rotate these things all day long. Yeah, the plasma fame is cool. When they did that one, I do want to repeat that. That's for sure. I got an old coil around here, man. I don't mind if it gets destroyed. So I want to do the plasma flame as well. So. Hmm. Some of this stuff spins from discharge. Yeah. Yeah, you can spin the top of it like that with ion wind discharge. The coils, not so much. They weigh a little bit more. Oh, Jacob's ladder. I did one of those on accident today. I did it a couple of times. I'm moving this anode cathode around, play with it, and all. Next thing I know, man, it's whoop, whoop, whoop. Well, oh, yeah, that's fun. Oh, I did it out of a Dr. Pepper can, man, and it was a Pepsi or 7-Up or something. All you got to do is take the coating off of it and sand them down just in a strip, and put them in a V, and you'll watch it ignite, and then whoop, straight up both sides. Jacob's ladder, man, with 2 soda cans. So any kind of metal will do it. Oh yeah, it kind of does, yeah. Yeah, I do all kinds of stuff with this thing, man. I love high voltage. I've been playing with it for a long, long time. So yeah, I did another one here. What was I doing, man? I was doing something. Let me see if I have it. That's not what I want. I'll pull a video file. What was this one? Oh, this is the neutron with my Tesla coil. And I'll flip the capacitance in the back once this thing starts. There it is. And just look at the oscilloscope in the back. As I make the switches, turn them, you'll see it either goes down or it goes up. And you see the brightness change of this thing. and the size of it. That's crazy, man. It gets to where you can't barely see anything. You see the amplitude go down on the oscilloscope in the back right there? You see how it got smaller? So if you're looking at it right now, see how small it is, and see the amplitude, which is the amplitude is just basically how big that wave gets in the back. So let's kick it back over to here. You see how high it is and how bright it is? And then how low it gets as soon as you change the amplitude of it. It's absolutely controlled by the capacitance of it. Yeah, that's really cool, man. I learned what broke the ZVS by breaking hundreds of them. Okay, let me just tell you that. Okay, but yeah, that ZVS is pretty awesome, man. That cap bank is too. Yeah, I figured out the secret to these, man. Yeah, Rab, right out of the Tesla claw. Right now, it's getting a ton of feedback. You can see it on the oscilloscope. As soon as it gets feedback, it brightens. Well, I'm trying to adjust it out a little bit, but the oscilloscope doesn't lie to you. It's telling you everything that's going on. And you see my hand over there, it's just changing the cap bank. Go with flat wire? Yeah, maybe. Probably work pretty good. That variable cap, dude, that's a life changer right there. Let me just tell you that. Yeah, it forms pretty fast too. Got this thing down to pretty much a science. There you see it here. I'll change the capacitance, go higher. And when the oscilloscope goes down back there, you'll see the thing get a lot lighter. There you go. They got a lot less bright right there. You see it? That's what it is right there. And you see in the back behind it on the oscilloscope how the amplitude's gone down. But if I go like this and bring it back, you see the amplitude's really high. So the amount of energy inside that RAV's really high. Then we change it back, it's really low because the amplitude's low. Yeah, I got this thing figured out, man. I know how to tune it. Yeah. I was creating these things, man, and it sounds like white noise. Basically an AC flyback, you're right. Bipolar Tesla coils, basically an AC flyback, depending on how you build it. 100% right, Dennis. That's why it works this way. That's why it has no problem making a RAV. And because each side is equal to each other, both the anode and cathode have the same resonance frequency going through them. That's why you'll see it go back on the oscilloscope sometimes, and it'll double up on itself and create packets. You'll do it every time. Yeah. Generally the 47, I don't know if you call them nanofarads or whatever, but the number 47 that's in the cap bank is the one that I'm clicking most of the times in this, and it has the biggest jump. In this particular coil, you need the higher numbers. If you get into an AC flyback, you need the higher numbers. So if I had like an 86, it would be faster to tune a couple of those on there, if that makes any sense. But if I had a row of like 10 of the 47s, not a problem, man. I'll be able to switch this thing in and out of different frequencies. By the way, the RAV itself runs at 94 kilohertz. This one runs at 264 kilohertz or 256, somewhere in there. And it still produces. So I hit a secondary resonance field in this in order to make it. Yeah, that's a lot. It goes quite a bit to tune it. It's not like a regular Tesla coil. Yeah, to be honest with you, Ian, that cap bank that you made me, I had everything on, and it dropped me 100 kilohertz, but still didn't give me the last 50. I needed a secondary cap bank with another bunch of capacitors to drop me lower. So to try to even get to 90 where Sean's is at. But it is what it is, man. It's just in tuning. Yeah, Tesla was working with a whole different coil, by the way, just so we understand each other. That RF was so much more in some of the coils he built than anything that I'm using. Yeah, we'll just play it. You can see it right there, super high. Super low, man. It said, just look at the oscilloscope in the back. It tells the story of what's going on. When you see it like that, it's like the double. That means that the resonance is bouncing back on itself through the anode and cathode. And there's changing. Gone up high. Real good, real bright. Very low in the back. You can see the oscilloscope right there. That's how you tune these things, Ben. You take that capacitance and you tune them. You can tune them as well, on some of these. So that's the mid tuning you can do. You can do a little front tuning on these. And here's what I mean. Do you guys remember when I did the magnets inside all the different coils? Well, it basically took a trigger switch and put it in there between the energy levels, right? And when I did that, I was able to add frequency to it. So I added a sine wave into it. When you do that, it'll change the frequency up and down, which will change the voltage and amperage going through this thing. So you could do it on the front side like that. The capacitors, which is the mid, there's one last way to do it, and it's high voltage saturation. So if you took the positive and negative on both of these sides and connected them into a little bar, You put the positive to positive here. Okay, negative to negative on this side, positive on this side. Tesla coil in here. None of them should arc over. Okay. What you'll get is the Tesla coil itself. We'll go and build a field around it. It'll encapsulate this high voltage positive and negative. It'll take the frequency and level it between all three. And then both sides of the anode and cathode will be equal, but they'll also amplify when you turn up and down your Tesla coil at that point. They're all interlocked in high voltage leaching. So you can do that as well. That's the final one you can do. That's the backside of it. So there's a lot of different ways to tune these things, and you can just choose your method and how you want to do it. So those are the three that I use, and they work fairly well to tune anything I want to put it in the frequency I need. The hard thing is, man, is when you start pulling frequencies that nobody should pull. You want over, I can get you 20 megahertz in a standard coil. I got one right now that's pushing over 100. And it's because of the super high RF that the way Tesla built its coils. I had to order a second oscilloscope. It should be here tomorrow to test some of this stuff. But that's really what you're getting into at that point. So, and those little coils, man, I did those. And I built one about the size, just a little bit bigger than a AA battery. And I ran the coil on the outside, the thicker, 14 gauge coil, and it'll oscillate just fine. And you could do it with an MPN. I believe I made a video on that. I made a video on that one. So you can always check back with that. But you can run those like that. I know you built Sean's, dude. Like I was telling you in the email, just thicken up that number one because I don't think it has enough magnetic, to it to fire off all those secondary coil the way you built it. I think you need a higher magnetic value is what I really think is going on there. So I had the same problem myself. And the ZVS will tap you at 1 megahertz on any coil that you build. If you just need to find oscillation, set up your ZVS and it'll give you 1 megahertz at max. And no matter how high the coil goes, it'll max it at 1 megahertz. So that's always, if that's all you needed, then there you go. Have I used the PNP? It's forced oscillation. So there's no spot for the ground since it's bipolar. I did run a PNP on a bipolar, didn't I? I'll have to go back to that old video and check that because I'm pretty sure I did run one on there. And if I did, then I should be able to do it on this one. You might be right. But it's forced oscillation. So you normally, it goes to the primary and then it's timing through the MOSFET itself or the transistor, and then it shoots the number 2 coil and forces it into resonance doing it that way by timing. It goes 1, delay, 2, 1, delay, 2, like that all the time. On this one, it might be able to do it. Now that I think about it, if we took one side of the winding and put it on there as the forced oscillation and then the center as our, I think we might be able to do it. I'll try it. I'll give it a shot. I think that's what I was figuring out last time too. Let's see. Yeah, it all depends on your coil, to be honest with you. Some of these coils you build to be in the megahertz, some not so much. So, but I don't know about the watts. I never calculate the watts, to be very honest with you. I find it useless. We're dealing with DC here, not AC, so I don't need that number. So I generally don't use it. To be very honest with you, the amps in this thing are minimal. The voltage is high. It's I usually say for every 10 volts you get 2 amps. But I've run this thing on a 9-volt battery, which is 9 volts and 8 or 900 milliamps. I got a nice field out of it because of the way the coils are set up. It's not exactly what you think on the amperage when it comes to DC. When it comes to AC, it is. So, kind of a different understanding. What's going on, Andrew? Nice. Yeah, you can adjust the resonance. Absolutely. Yeah, you're adjusting the capacitance and resonance at the same time. You're looking for that amplification. That's what you're looking for most definitely. Sometimes you have to fine tune the little guys to get that amplification just right because it likes to jump up and down on you a little bit. Sometimes you have to front tune it to fix that because you'll get the resonance frequency, but the amplitude sucks. So you got to go back to the beginning one and change it so that you can get the amplitude to go higher when you change the capacitance. I've had to do that several times. It takes longer and it's annoying. Let's see, times 8 according to Mr. K. I'm not sure who Mr. K is. I don't know because it all depends on what system they're working in. So I'd have to see that before I could tell you. I have people tell me they built a coil like mine, and I get to it, and there's 5 coils on a PVC pipe, man. Nothing like mine at all. So yeah. Tuning across, well, it self-tunes. The Slayer does. That's why I think it'll probably work. You know, I can look to see if I did that one. I'm pretty sure that I did, and I used the diode, which makes it. Every time you use a diode on something like that, it makes mountains on your oscilloscope. It goes up and then all the way back down like a big M. Except for the center part of the M doesn't go down below the line. It always stays above it. What happens when you start playing with diodes and this stuff? Mr. Keshi. Oh, from Bernie's channel. Gotcha. Let's see. Let me go, let's see, bipolar. And we did a Slayer. This is the Slayer exciter circuit that I took the reference from. You can see the transistor is a 25A1962. It's a PNP. And that means we're pulling the negative on this one. So we got all the connections made. Now I made a modification over here. And I put 2 diodes in here. This is a 400 volt 3 amp diode. This is a 100 volt. Yeah, don't bother putting those diodes in. They'll screw up your system. Let's cut that part. Air exciter, I don't think I would expect it to, but you never know, and so I put it out there. But I just wanted to see if it would oscillate. Now, why the diodes on the bottom there? Well, I'm trying to break the ground wire coming in side of where it picks up the energy. So maybe it works. Maybe all I did was shorten my Tesla coil. Who knows? Give it a try, see if it even works, and then we'll go from there on what we need to do. So, with that said, we're going to check the temperature on this as we go on our transistor. So at 15 volts. Oh, so we got light up at 15 volts. Okay. That means I have a little over 2 amps in it. We went up to 19 volts. still lighting up. And got light up on that side. Not as consistent as I would like this to be. I don't have any fan running on this, so let's just check. Yeah, we're in the 70s.
Nice and cold.
So we're good operating voltage. So let's go ahead and bring it up a little bit. We are now at 30 volts. See if our light gets any better. Our light got better. That's good news. Yep. Light's fairly good. By no means is this the same thing I get out of running it in normal configuration, I can tell you that. But it is lighting up. And at 30 volts, we're still in the 70s. That's still well within operating. So the connections, I just have it connected to the top. By no means is this set to oscillate in any different way, so we can change that. The other wire is standard. It just goes back down. Again, with the schematic I gave you, I haven't changed anything there. So let's take a look at our oscilloscope and see what kind of waveform we get out of it. So I just have the probe here. What I'm going to do is I'm going to bring it over this side, then I'm going to bring it over this side. So I'm going to show you the oscilloscope. There we go. You should be able to see that. We're over the right side now.
Yeah, it's that diode
Certainly interesting.
making mountains.
We'll go over the left side. Let's see, we'll move back to the right side. Trying to keep everything at about the same height. We're about 3 inches off the coil right now. Again, we're not getting a massive field. So let's put this over our primary. Then it's almost nothing there. All right, so let me see if I can't. That's our output right there. Yeah, we don't have near enough power in this thing, that's for sure. This is probably why it's always done with a spark gap Tesla coil. It's okay. This is what testing everything is.
Yeah, so to answer your question, Ian, yes, it did work. I was trying to put the diodes in the bottom because you have to run the transistor part that forces that oscillation, and I was running grounding at the same time. And I didn't need the grounding. I actually cut it off later and just ran the forced oscillation into there and got rid of the diodes. Yeah, those diodes are kind of a mistake. You saw that the disconfigured in the oscilloscope. That's what the diodes are causing. So later on, I just cut out the diodes and got rid of them. And because it was bipolar, I didn't need the grounding. So I took out the grounding wire and I just ran the forced oscillation wire, up to it, and it worked great. So why would I have the full null area cover? Because it's a bipolar Tesla coil, and that's the way they build them.
Yeah, normally I run 2 coils. Normally I run a straight single and then run it off to a secondary coil, and then it has the null zone in the center. But in a bipolar Tesla coil, the null zone is right there where that primary is. That's why it's covered. Just different type of coil. Yeah, but you can run it with a Slayer Slider. There you go. So the question answered. And you can run it actually with the ZVS even better because it doesn't require the ground. So it's one less wire you have to run for your ZVS Tesla coil. Because normally, in the one that we normally use, they have the wire that goes to the secondary that goes down to the ground. Not needed in a bipolar Tesla coil either. So pretty cool stuff, man. That's what happens when you test everything. You get to find something new all the time. Yeah, there's no grounding in a bipolar. What it is depending on where you put your primary at, one side's more magnetic than the other. That's it. You're when you're dead center, they're equal. Okay, they're both equal. But then when you move one side, the side that has the shorter side becomes more magnetic, and then the other side becomes more high voltage. And there'll be a difference between the two when you do it that way. So you can adjust that as you want. So again, this is why if you leave a little bit of your Tesla coil at the very bottom, that when you put your primary up, say about an inch, that's why you're going to get a north and a south on it. But when you put that primary all the way down at the very bottom, or you run it 90 degrees, you're just going to get one pole. Okay. That's the difference. That's because you're building a bipolar Tesla coil at that point, and you're not running a single pole, a monopole. Nice. Yeah. Let's see. Yeah, one of the things we need to do in here a little bit is start winding transformers. And there's a very specific reason for it. When you want to build this kind of stuff and you want to build it into lower frequencies, you need to add mass to coils. And you can do that to the ground or, through the ground wire, and you can just add the transformer there. But you're going to need to add mass to them. So what do I mean by that? When I put on my primary pillar coil, my second coil coming out is no longer going to be a hollow tube. It needs to be a transformer wound to the exact frequency of the driving coil. So I need to lower the frequency of the driving coil, get it to a second one, get that exact frequency in isolation from a secondary coil underneath it. And if you could do that, then we can resonate it, pull the power out. Then as the power is excited in the upper coil, the lower coil below it will be able to take and transform the energy into a different frequency and a different voltage and amperage. And we should be able to lower that down to usable voltage. If you can understand that, then you understand the energy conversion. That's exactly what we have to do here. We're going to be changing it to resonate properly, then drop it. So, and by doing that, we should be able to break the frequency right there between the upper and lower part. So it's taking a while to get to this process, but that's how we're going to have to change it, just like they do on the pole outside your house. We're just going to convert it the same way. So. Yeah, those aluminum caps are way better for higher voltage, by the way. You're absolutely right in that. I like the blue ones better. So the aluminum, yeah. Nice. Yes, that's the point. Once we match the resonance frequency, it'll be able to take it in, and then I can convert it to do real work. Basically, do a Floyd suite. I could take high voltage and turn it into low voltage and bring up the amperage. We're going to pull a Floyd suite on this one and change the energy. Just do a straight up conversion on it. Yeah. Yeah. We'll get more energy. We'll be able to control our voltage and amperage because we already know how a DC system works. Like, there's no lying about this. Okay. We know how it works. Okay. We know that we lower the frequency, it brings more amps into there. That's it. The higher the frequency, the higher the voltage. So we're just going to change the frequency on the back end of this thing. Once we obtain this stuff, man, we're going to transform it. Because all the other ways, they're okay, but they're not doing what we need them to do. We need to change the frequency of this and create a change in this. Yeah, we can. By the way, in case you guys didn't catch the one that I did, you can run a NPN circuit right off of your Tesla coil number 2. Because you can use that thing as saturation instead of electrons and holes. You could just use your NPN as saturation points. When you do that, it'll oscillate a Tesla coil just fine. So if you counted that as part of your coil when you tuned your primary coil, that secondary sitting out there by itself, you can just run 4 or 5 different NPNs off of it and create 5 oscillating Tesla coils right then and there. Fairly simple. There's some tricks in there. If you're watching the videos and you're seeing what I'm doing, there's some funny conversions that'll go on, and it's always useful to take notes of that. PMP is just a little bit different. Different way it works. PMP is a beautiful way to do things, especially on, say, rodent coils and stuff. Oh man, so much better. Yeah, I put the hidden things in there, man. I should just flat out show you the good stuff, but I want to see if people catch on. Some of these things, man. That's why you get somebody like me who tunes things all the time. Nice. Yeah, I like Don Smith stuff. There you go. Well, he was changing the I want to say this. He was cutting frequencies down. Because if you looked at it in a backwards format, the frequency would be, say, 5. And that's how it goes, like this. 5 things went like that. And he would say, okay, let me cut this down to halves of each one of them until he got to a very low frequency. And he could change the thing, the harmonics of it. There you go. Don Smith was great at changing the harmonics of it to get it to work. That's all you have to do. You have to understand where the points of amplification are. Once you get that set up in your harmonic, then some of this stuff's easier to change. Yeah, the good stuff's hard to get. Yeah. No, not for long. I'll tell you that right now, not for long. I have some stuff that I have to release here in about another year or so. But before I do, I want to get a bunch of this other stuff out. What's going on, brother? We're going to get to your geometry coil here, man, on the other channel here pretty soon. So take a look out for that, man. The next few weeks, I'm going to start doing all my geometry coils for those who weren't here in the beginning. I'm going to start winding them and go straight out, man. I'm going to write down all the numbers on there and start winding them and show you a top-down view of exactly how I wind this thing. So we'll be doing geometry coils. We'll be doing rodent coils, bunch of different coils, some different designs of them, the circuits for them. And I'm just going to show everything from here on out on all that stuff on the other channel. I'll just make it a geometry coil channel. You know what I mean? And then we'll still do all the lives all combined like I'm doing right now. And then I'll also show you the CAD work on my printing channel so that you can see exactly how to build it in Fusion to change everything that you want to change if you want to do it yourself. Or you could just, spend $3 or whatever for the STLs that I put out there and help me fund the next build. So it should be pretty good, man. I'm going to race it for the next year before Tesla Tech. That's my goal. I want to have every single coil that I could possibly build before Tesla Tech of next year. So, have you ever tried making a plasma chamber? I have not. Jeff, man, if I knew him in the 80s, man, I'd have no life. I would have been doing this all the time. That was like the prime time in life, you know what I mean? I never would have had gotten married, had kids, anything. I'm glad I learned it now. Now I have time to do some of this stuff. I wouldn't have then, man. Not at all. Right on, brother. Switching the center part of the coil side to side so that you're saturating both sides before switching. No, I have not tried that. I've not tried that. Read that again. Switching from the center point of a coil instead of one side. So you're. I'll tell you, I did something similar but different. You know how I just put a rod down the center of it? Well, I took the time and built windings on the rod that I put down in the center of it. And you guys have all seen me put another Tesla coil down there, right? What I was looking for was I wanted to pull different frequencies with different heights and see if I couldn't get them to layer when you put them out. Because otherwise, they just, same frequencies, they keep one mesh zone. I was looking for layered scalar. It did that one. It didn't work out so well. Okay. So I kind of abandoned that one, but I did try it. Let's see, switching both sides so the coil is fully isolated. No, I've not tried that one yet. Yeah, one of the things I'm going to do is add mass to these things. So, yeah, that'll be a big conversion in itself, man. Be able to isolate this stuff a lot faster. And the scalar needs a mass. If you've ever been in scalar, you need mass. So, kind of a different understanding than most people would teach you because they have no idea. But that's what you need. You need more mass. And that's why Tesla weighed his wire instead of looking at the diameter or anything else. He weighed it because it's about the mass of it, not anything else. That's why a tuning fork can turn on a transformer. It just has to do, hit with the exact frequency. And a transformer has more weight to it. A regular sized one has more mass in it. And it'll change the frequency much faster. I've seen motors without metal in them. They 3D print them and they make them. I've seen those. Primarily to be free floating. I guess you could. to allow for some motion. That just screws up your frequency both sides, but you can do it. I've seen people do it. Well, matter will lessen the plasma and give you more of a scalar field. Well, you do know why he's trying to run it the opposite way, because he's looking for an amperage draw out of one of them and a voltage draw out of the other. That's why he runs them in different directions. Nice. Yeah, I can see that. Yeah, there you go. Mass. You got to deal with mass if you're dealing with scalar. You gotta weigh the wire. So nice. But yeah, everybody's gonna be watching it, man. We're gonna run for it, man. We're gonna go for it all. Yep. Well, it is, because it's what lowers your frequency. So let's just understand this, okay? The more windings you have on a coil, the lower the frequency it is. But if you think about it in terms of weight, if you weigh all the windings of the copper, okay, what's the mass? Okay, what's the weight of all of it? Now, if you take a transformer that has triple the weight, you're adding more mass to the coil because it'll add together to lower the frequency even more. That makes sense? The more windings, the lower the frequency. The less windings, the higher the frequency. So if you take the mass of the core plus the wires, weigh it all together, that's the mass you'll have for the frequency that goes into it. That's why transformers that are solid with metal around them have a much lower frequency than a hollow core does in itself, right? That's fairly simple. I think everybody here understands that. But now we have to start thinking about it in the way of, we're going to use one to create a field to make the other. Okay, we're going to have to be able to break it and transform it. We've all seen me take my rodent coil and break the frequency and not allow it to change from that point on, so it continuously runs. Well, we'll have to do the thing on the backside of it. Once we do that, then we can start transferring energy and change the mass and change it to a lower frequency. So we have to do. We have to pull a Floyd suite on it. So, yeah. There you go. Yeah, you guys got it. Am I saying? Yeah, I'm not just staying on the YouTube platform. When I say other channel, I literally mean I have 3 channels on. If I can put up the number 3, I have 3 channels on YouTube right now, and I have been doing a podcast on one, and I failed at it miserably. So I'm just going to change that over to a winding coil channel. And then I have a 3D printing channel that I haven't used very much, and I'm going to use that one to show out all the CAD work. So, yeah, I'm staying on YouTube, staying on all the other platforms that I'm on, and I need to hire somebody to get in here and help me get it all fixed out so it stays up to date. But yeah, I'll link them in the videos when I start the channel and get it up and going. I'm going to start linking them down in the description so you can find each one easily. But no, I'm not coming off of YouTube. So it's taken a long time to get us up to this level, man. I'm staying right here. There you go. Nice. Yeah. I didn't want to put any confusion out there. Yep, we are staying. Absolutely. I wouldn't go anywhere. I don't have any plans to go anywhere, man. I plan to build this thing a lot bigger. I had a couple buddies go on and they wanted to audition for another channel, like to get on there and to show their stuff. And I don't care for that. I just don't. I want to be a big enough platform where other inventors can come on here and share their work freely. Put out that they got a Patreon and everybody can go and watch it. You know what I mean? And go and help them out and just kind of give back to the community. I have zero interest in playing any type of games or trying to, run somebody else's life. Dude, I don't do any of that stuff. You got a cool thing you want to show, man, by all means, come on and show it, dude. That's the way I am. And I don't give anybody the business. I'm not a gotcha channel. Not what I want to do. And the more that I can get out there and do all these experiments, the more understanding of everything I have, and the more all the audience has an understanding of it, the more the guests come on and feel comfortable talking about it because you understand it. Dude, we're all good. Okay. This is not a physics breakdown channel. This is not any of that, man. This is a old man sitting in his garage, converting it to a studio and just building the heck out of everything in sight because we have the ability to do it where others don't. That's it, man. That's what I love to do. So, and I love people to come on and promote their own work, man. As long as it's yours, promote it, man. And if you rebuild somebody else's stuff, give the credit to the creator. You know what I mean? As you do your work, I'm good with all of it. I'll promote whatever Patreon you want, man. I don't care. I mean, if it helps you get all your stuff built, absolutely. That's the way it should work. And I don't like to play any games in the meantime with any of it. Just not that kind of a guy. Nice. Yeah. Well, as soon as everybody understands it the way I understand it, man, it is just so much easier in life. So much easier. A lot of this stuff seems overcomplicated because I know numbers are great, and a lot of people like to measure things. Okay. Sometimes it's the feel. You got to go by your gut and the technique that you use to do things. And then you can kind of get it figured out a little faster. And then you go by and write down all the stuff that you need to and put it in your little book and you have all the measurements you want. But it's got to be, from in you. You got to pull that out of yourself. Love it, man. Love it running these different things in here because a lot of people are confused. There's a lot of NPNs running backwards and a lot of these systems, people wouldn't understand it. Like right now, I told you the Tesla coil thing with the positive and negative and the high voltage, right? You could right now go in and do an Edwin Gray. He had a coil, and you'll read this in his paperwork, that you can put a ring right above it, and you can turn on the high voltage and it'll do absolutely nothing. But as soon as he turned on the Tesla coil, it turned into high voltage AC. What happened to the ring? It shot like a rocket right into the air. Why? Well, because the energy coming out of it was completely different at that point once you added that Tesla coil into that equation. Now you got more amps in it because it grew capacitance. So if you ever wanted to look into Edwin Gray and you want to figure out that part of the story, it's right there. That when I showed that on that channel, that's a big deal. You got to understand how big of a deal that is. That's not normal for people to know. Okay? Not a lot of people understand it or know it, but it's why aluminum goes anti-gravity on you in an AC field, but you need the DC fields as well in order to make the bubble. So you'll have the best of both worlds. Something to think about. Yeah, well, that's why I do it individually. So On this channel, we usually do Tesla coils, right? We're doing the RAV, we're in the Tesla coils, we'll get into Bedini, okay? The other channel is going to be geometry coil. We'll do rodent coil, geometry coil, you know, those smaller coils, things like that. More of the winding side of it, okay? Then we all get together on the lives and we all have fun and conversate, you know, through everybody. Meet new people, everything else. We'll get rid of the haters like we always do, man. Yeah, no time for those type of people. Anybody who wants to learn, they can do it. Be able to watch the videos, and hopefully in there, I've learned enough to be able to show you the construction method properly. And I got yelled at enough to make sure that there's a diagram and everything. What's going on, Lulu? Hopefully everything's well. Yeah. Well, some of them do, some don't. Nice. Normal life. Right on. And one thing I will do on here, just so you know, on this particular channel, and I might just do it on both, is the Tesla bifilar coil, the way Tesla built it. I have one the way Master Evo built it. We're going to do it the way Tesla did it. So that's something people have been asking for, and I've been reluctant to do it, and I'm going to go ahead and do that. So, right on. Yeah, it's hotter than heck out here, man. It's 100 and something degrees outside. My air conditioner does not like it here right now. Huh. Right on, brother. I knew you'd like that one. You mentioned every time I build one of those, and I'll be honest with you, man. I held back for a long time because Gerald does one, Ben does the other, but I don't think that thing will ever change, man. So, you know, the dynamic it's in now. So I'm just going to do it all. So, right on, Paul, my neighbor Paul. I hit 8.5. Nice. Well, hopefully, you know, next couple of months, man, we get up to 9,000. That's kind of the goal. And I'm gonna have to do a lot more work to get it there. Put out a lot more videos. Like I said, I've been working on everything back here that you can't see, but it's gonna pay off big time. And I'm transforming everything so that we can start doing the shows the right way. And I have less work setting up. Thank you, Paul. Paul's a great neighbor, man. Awesome guy. Yeah, I won't have a problem building those. Those will be fairly easy. There's a lot of stuff out there with the people who've done it right, and no problem in there. The heat should bring some rain. We had a flash rain, man, a little while back. It was kind of weird. It was kind of muggy outside, and then it was kind of rainy. And then usually, if you're back east, that means the tornado's coming. I was up in Minnesota one time when they had one, and that's exactly the way it felt. Right on, brother. Yeah, Gerald's doing a lot of uploading. Yes, he is. I knew you would like that, Ian, because you're going to probably wind everything I wind. So we'll both know if it works properly. Yeah. Hey, we're going to go through some hard times, though. I'm going to tell you that right now. Hey, nothing going to be perfect out of the gate. It's going to be some trial and error, Ian. It's really going to be that way. I got the one winding I'm going to do. I was mentioning earlier, and I'll mention it again so you see it. This is where my first geometry coil is going to start. And what happens in this is I built this so that I could put these wood dowels in here, because I hate it when you take things out of everything and then they lose the compression value in it. You know what I mean? The tension that's going on there. So we'll build these just like this size, so it's nice and easy to be, everybody can see it. It'll have a second plate that comes over top, just in a ring that goes around the outside, and then we'll be able to set it. And then I left other holes in here on the off, so I can just put little plastic bolts in there and shrink them down. Okay. What it's going to be is it's going to be able to let us have compression on the outside. It's going to pull them tight. It's going to keep it in the form at all times. And then we don't have to mess with it again. I do not want to put a bunch of glue on there. I do not want to put a bunch of resin on there. I want to run them the way that they're done in a day, and I can start testing on them. And then if we get to the point where we like it a lot, then we can put it in resin. But I'm expecting this center part right here to have all the energy, and the pattern in it. It's going to have the pattern, but it's going to twist up when you look at it this way, and it's going to twist down when you go in this way. So it'll be two coils built into one. So we're going straight at it, heavy and hard, man, the right way. And we're going to hope to God we don't get cancellation. But I think we'll be okay. Right on, brother. I appreciate that. Nice. Well, I hope they don't vibrate. I hope they resonate. And I hope they do it on an atomic level, not at a, I mean, a regular vibration level. Yeah, well, that's kind of the point. We're going to see if we can't do it, because I learned the secret of how that works. Right on, brother. Appreciate that. Yeah, and I'll send you the as we do each wine. I'll make sure I send you that STL so that you could do the same if you wanted to build it. Yeah, we're all on the same page, man. We're getting there. Then you've been watching. You understand why I'm going here. It's all about the trick to the gravity flyer that most people don't realize. Got to create that null zone, but you got to pump it. That's why these people in their papers will fail, because they don't understand that key factor. You have to be able to do it. Vibrates like a speaker? Well, we'll find out. We're going to find out for sure. That's cool, though, that yours does the vibration, though. That's pretty awesome. Yeah, I generally don't levitate much, to be honest with you. I told you that thing came off the ground, right? Well, there's a reason for it, and I found out what it was. Yeah, it could work. I'd like to try silver. Once we get some coils that we know work really well, then I'll invest some money into some silver. Or if they got a gold wire, that'll be pretty expensive. But if we can make a small enough version, it might be worth testing. Nice. Well, anti-gravity is completely different. If you don't create the field bubble, you don't have anti-gravity. But then if you don't pump the ether, you don't have you don't have a vector direction, you do not have a gravity well. That's why Jack Safari doesn't have it. Now, I'm not going to tell him how to do it either. Hmm. Yeah, I don't know. I haven't seen the coil in action. I couldn't tell you. Yeah, levitation is it's an AC wave to aluminum. Matter of fact, I'll tell you who did a good job on that. Oh man, I was just watching it a little while back. He built a bifilar Tesla style coil, put AC into it, and then he had magnets. It's Jeremiah. It comes on channel once in a while. They had magnets, and they were flipping, and they were floating above the coil. Man, he did a little video short of this thing. Dude, amazing work. He did absolutely amazing on that. It was one of the coolest things, man, for like a levitation experiment. I thought it was out of this world because he had like 4 or 5 of them set up, and they were all rotating around on a certain degree. Okay, every one of them. So there was different resonance points in that bifilar that he found, and then at those points, it went to the magnet itself and where that resonated at, and it would cause it to levitate and swirl. You see, you're wondering why we do the RAV and what's so exciting about it. It's not the camera things that are exciting. I think people miss that. When Sean showed the camera and we showed the temperature differential, the resonance differential between them, that's money. That's undisputable evidence of how it works. That's why you create the RAV. Because it has to do with all the harmonics in it, has to do with why it's working. It has to do with how the gases are building out and the coloration of the gas itself as it builds out. Yeah, there's a lot more to it. If you think it's just a camera effect, yeah, well, they never get anywhere. You'll never understand the true meaning of it. And I'll tell you what, there's going to be a lot of people who are going to try to create a lot of ball lightning and fail at this because they do not understand this aspect of it. Even the people who are experts in it are missing it. I can guarantee you that. Yeah, see, you got it. It's why, let's say this, they're trying to heat up the plasma and contain it instead of trying to resonate it and put the correct capacitance in it to amplify the resonance itself. That's why I was showing you that picture. I'm showing you the low amplification building out the low amount of energy. But when I give you the high amplification, we're building out the energy in a much bigger way. There's a reason I'm showing you that. It's because as you build these things in resonance, that they're self-correcting. Okay, they already build the rings correctly. Okay, they already put it out there. The geometry is already done for you. All you had to do was understand it and understand where the amplification comes from. You see, they're just trying to throw a ton of energy at it, so it's an energy loss, right? Where you're throwing capacitance at it and changing the frequency just a little bit. And the most valuable thing you're doing is changing the amplification level of it. As that oscilloscope goes up like this, you're changing that amplification level. For anybody who's run a Slayer exciter that I build, they go everywhere. Everywhere. Why? Because the amplification is through the roof. You get into ZVS, it goes down quite a bit. You get barely anything for the same frequency. It's the reasons why you do these things. That's what they miss when they go to put it in there to create the reactors. You don't even need to necessarily pull it out. You just need to build the transformer that matches that resonance frequency and convert. That's it. Just let the thing run on its own. The confinement will stay in there as long as you put the lead on the outside where you can't get the radiation level, because that's really high radiation you'll get when you put in the correct amplification. You want to change that factor. You want to hold it in just so you don't get the radiation out. You're not trying to compress it. If you want to compress it, you do it in the capacitance of it. They don't understand the resonance of it. There's rarely a few people in those industries that would ever understand what I'm talking about. They don't get it. So, well, I'll have to write the paper and do it along with Sean and Joe, and then hopefully they'll read it and they'll get it. Not once you break the frequencies from changing, you can convert it any way you want. There you go. We're on the right track with the ghost worm. You know that. If you've ever read up in any of this stuff, you know what that ghost worm was. Yeah, this is we could do a freehand. I don't know that I need their calculations to do it. I'll be very honest with you. I just understand it better than that. They got shocked. Nice. Yeah, that's why they're creating super hot plasma. We don't have to. We just have to create cold plasma, which doesn't mean it's not hot. It just means it's not nowhere near the temperatures they get it. Yeah, it doesn't have to be. You saw the temperature difference. We're well over 100. What is it? 100 Celsius or 100 Fahrenheit difference between each ring, and they come out different colors. Clear as day. Clear as day. Massive temperature differential, and it's all self-sustaining, and it all stays in the same zones, and it all has a null zone in between them, where it reaches a saturation point between each one, and they're in spheres, not in circles. I got through a lot of hell over the last day about that. Drive me nuts, man. We don't show it right. Yeah, well, it will be cheaper, that's for sure. That, and I figured out some tricks to certain things that might make it even better to do in the way that it configures. So, yeah, we'll really get it going there. So, I've already come up with a lot of different tricks and tuning this thing, and I've been asked to hold it back until we write the paper. But man, I made some cool stuff. Yeah, not by computer input, no, because they don't know what you're doing. They have to be told it at one point in order to think that way. They're a regurgitation machine. If somebody doesn't know it, and if nobody knows it, then how's it going to regurgitate it to you? They can't. They can't. They're not thinking for themselves. The computers aren't that way yet. Oh, there. I take 2 seconds to turn one of these things on, and we can make them more stable. But in everything, you got to remember when I tell you it's string theory, they're going to oscillate inside out, just like this. You got to remember that in 360 degrees, they're in continuous oscillation. So while you can make the thing go coherently, you're not going to take this out of it. It's going to continue to pulse. If it didn't pulse, it wouldn't work. It's that pulse is the difference between creating a gravity well and having a little bubble that's like fart in the wind. Okay, that's the difference. That pulse. The only thing is string theory shows it in 2D. They need to show it in 3D, and then they'd have it. They don't, because they don't understand resonance well enough, and they do not understand geometry hardly at all. Sorry, I've seen that firsthand. Sapphire project, yeah. Well, we're not blowing out the anode here. We're using stainless steel so it stays at the temperatures we're in. Yeah, well, you're going to see it. Once you write the paper, you'll see it. No question. I have it all documented. You'll see it. Hmm. One thing I would like to do is once we have the paper written is presented on APAC. That'd be cool. Presented on any channel that'll have us. That is one thing I would like to do. Once it's all written and documented and done, and we did all the math on it, then absolutely. Oh, we're gonna archive it to the world once it's done. Well, once it's already printed, I could care less. I'm not into super peer review or acceptance or anything like that. I just want it out there so that it's known that we did it first, and then I could care less. Okay. Honestly, I care less. I don't plan on filing 50,000 freaking patents for anything. If Sean wants to, he's more than welcome to. But at that point, I would be done with my part in the whole thing. That's enough for me, man. Creating it, writing it down, doing the math the way physics likes it, and then I'm out. That's enough work for me. So I have other things I want to get to. Transmutation on the electrode. Well, we're not going to get any transmutation on the electrode. That's not what's going to happen. I've run this stainless. Doesn't affect it. Check the weight. Doesn't affect it. You can heat it up, but it's not going to affect it. Have not had any form of transmutation on the end of it. It's solid. And if you know that, I'll say this. I'll wait till later on that. I don't know if I can share that or not. But yeah, there's a lot of power in these little things. But think of it. You have 3 isolated resonance frequencies that you can hit. Think about what that does to a coil. So if I set up a coil with those figures in it, you go, oh my God, we can amplify this one, and this one. And does it add to the energy output once we get it? Because they're in a certain band that coil would have picked it up in anyway. You see what I'm saying? Like a number 2 coil by itself, there's a band in it that it could pick up the energy in. Okay. And it's a very, within a couple of kilohertz of each other band. But these 3 rings fall in that. So do they multiply each other in there, or does it come out as one? I don't know yet. That's one of the things we got to do. We have to build the coil to match it. So that means that where normally I'm at 250 to 300 on my Tesla coils, it means I have to stack 3 of these things or just wind them one giant one and combine them together in order to get down to that frequency to be hitting close to exact on it to match the rab to pull the energy. Or I could start wrapping it in mass into a smaller transformer with the winding. So just understand that there's 2 ways to do that, and that's what I'm going to do with the core running through it, just like an AC flyback has with the core running through it. Then that'll add to the mass of the coil itself, because it's like putting the rod down there and add it to the mass of it. And then I'll wind it like Sean does, multiple wraps. We may be able to pull that frequency out right away. Nice. Yeah. Thank you. Yeah, it could be a multiplier in it. We don't know yet. We'll have to build it to find out. It may just be one frequency we get out of it because they're so close to each other. Yeah, I appreciated him stopping by, man. I hope that we have another more productive conversation next time where we're not talking about camera effects. That would be nice. But I think once you write the paper, they'll understand because it won't have one camera effect in it. Nice. I hope it does. Oh, really? Well, we're looking for Ian, just so you know, we're looking for a short stack at I'll get you the exact frequency. It's around 97 kilohertz. Right in there. I'll double check that number and send you an email. But that's what we're looking for. So if you got one that's at 67, then let me know the size of it and we see if we can't calculate the mass to it and get the the additional amount needed to get to that number. Even lower with cones, nice. Right on, man. Let's do that. Yeah, let's hook up on that and we'll do that because it's going to be awesome for people to see it when you just go like, well, this is running over here, but by the way, you've turned on this coil. And they go, well, how many did you build? Well, I built 20 of them. They turned them all on. Oh, well, you had a multiplication factor? Yeah, but then when I built these 20, I built another 20 and they turned all those on. Oh, you see what I'm getting at here? We'll make a solar system out of this sucker, man. I'll do it all round coils if I have to. What's up, Joe? Getting here towards the end, man. We're doing some good work on stuff, man. Ian's got a coil that's 67 kilohertz, man, and he says we'll be able to get it right around the 90 something we'll need. So I'm gonna get with Ian on that and work that out. So it's gonna be awesome. Yeah, we're gonna get this thing really good, man. Freak people out. I don't think they understand it. They will. I want to build one of the next ones. I have two more geometry coils that I want to build out when we do these next. Just so you know, we have the teardrops, so the hourglass. So it looks like a teardrop on the top coming down here to a teardrop on the bottom. Or if you like the analogy of the hourglass where it's fat at the top and then comes down skinny and then goes fat again. I have that one on my CAD already. And once we're done with that one, I want to build the round sphere. Sean sent me the STL for that. Now that I have the printer set up to print it, I'm going to print that and we can build that round one and we'll do the Death Star coil. I want to have that one in the arsenal when we build this stuff. I think it'd be really cool. So, yeah, I want to do some more geometries, man. We're going to do them pyramids, one to the other. And so far, I've only done it in bipolar, and I want to continue that for the next set of coils. And then I want to move on to single coils in one direction. So, yeah, kind of something a little different. We'll get into weird shapes too, man. I'm all good with that. What was that other one I wanted to do? It was a hexagon, but like a 3D hexagon. I don't remember the name of it right offhand, but that's the one I wanted to do too. Right on, man. Oh, Sean messaged me again. I'll have to look at that when I'm done. Well, Daniel, tell us what kind of help you need, man. Maybe everybody will be able to help you. To be honest with you, Sean got me Sean's an awesome guy. He got me this winder, man. It's an old school gearing winder. Coolest thing in the world. Okay. You put it on there, it doesn't go too fast. You know, your hand cranking it, but the gear there makes it spin a bit faster. But when you're doing these deep groove coils, man, it's the best thing to use. I wouldn't use another winder, to be honest with you. It is so nice to use on this. It made my life so much easier. I just had to buy a file to shave down any of the little boogers that it puts on there from your 3D printer. So if you get a real thin file that's under 1 millimeter, you'll be able to go inside the grooves and then hit one side, then the other, like this, and then smooth both sides out. So as you're winding it, you're not catching on anything. So, but then I changed my printer head. I usually run a 0.06 nozzle or 0.6 nozzle on there. So I run things fast in prototyping. I had to go down to a 0.4. I put in the 0.2 and I started dying laughing. I don't know how Sean does it. These must have super fast printing powers, but I don't. So, yeah, that 0.2 didn't work for me. I had to go to a 0.4, but I think I could still pull off as long as I change the retraction speed, get less boogers in the print. We should be good to go. Oh, wow. You found. Ah, that's amazing. Let me see if we can't pull that frequency. I'll get it for you real quick, Ian. Let me see. Yeah, I know you can't see it on there, but it says one says 100 kilohertz, the other one's at 96, and I believe the other one's at 92. So if you got 91, we're already right in the ballpark. I think 96 is the optimal number there. So yeah, that'd be really easy. That's just, man, that's not much. That's just a little bit of difference in winding. That's it. Nice. And is that the short stack that Sean sent you, the STL file? Nice. Yeah, I got the file so I can wrap it. Just give me the number on each zone that you put in there, because I know you calculate everything. So how many turns did you put on each one? And then I'll just run the short stack. I'll just print it off and run it. I'll make that my next coil I wind, and then the size of the wire you use. So I'm sure it's like 32 gauge, and then yeah, I'll be able to pull it out. So let's see, we got a little bit of higher frequency we need, so we just need a little less winding on there. That's not hard. If you calculate the winding for each one of the levels and convert that over, we should be just fine. Be able to figure it out, no problem in the math. I wanted to work with Bernie on something, man, to be honest with you. He needed to put frequency into something, and there's two little parts at Amazon. I think I'm just going to build him the circuit and send it to him. It'll be so much easier for him. He can attenuate the frequency in anything he wants at that point for everything that he puts into the monatomics. Yeah, that'll be so much easier for him. I don't know that he needs Tesla coils. I know he needs that circuit, though. So I think I'll just build one for him. We've been talking a little bit back and forth. I think that's what he wants. Thank you very much, Ian. Thank you. I didn't realize it was that close in frequency, to be honest with you. I'll ask Sean if he's got one and to check the frequency of it, because he may he may have one close to it and be able to check it right away. Nice. Thank you very much, Ian. I appreciate that. Yeah, I'll be honest with you, man. If there's some certain things I'd like to do with some nano coating, and if that's what he knows how to do, man, that's gonna be awesome. Like I don't even know how I want to say it. There's a lot of things I'd like to nano coat on the outside to speed up the ability of it. So yeah, a lot of stuff Bernie will be able to help me with. Yes. I have a gravity flyer one planned in the next couple of weeks. 0 point energy, absolutely. I could talk to Joe. We could probably talk about that on Friday. Not a problem. The gravity flyer, I'm just waiting on a couple things. I remastered some things, and my second gravity flyer got ripped apart to do it. My original one's just sitting to the side right now. But yeah, I'll definitely do that. So yeah, Joe says we definitely can do some 0 point. I think it's going to be needed because I'm going to go into some coils that are really going to be able to do it, man. So yeah, I think we really are kind of changed some things here, man. And I'll be honest with you guys. You guys have helped me out. You know, buy T-shirts, buy coils, stuff like that, and all that money goes into building the next experiment. So I ordered wire for the geometry coils. It's going to take a lot more before we're done. So anytime you guys can help out with that, man, perfect. I appreciate it. It go right to building some of this stuff. Awesome things, man. I know you guys already take care of me enough. You know what I mean? I'm just saying I want to give some value back. I'm going to put some of those things on sale. So if you check out my Esty account for my Tesla coils, I'm going to go on there and reconfigure that. Put some stuff on sale for you guys. And that way I can order more wire and we can start building more stuff. So you get a value out of it just like I do. Anyway, that's it for today, man. We had a great show. Hopefully I answered most of you guys' questions and you guys understand the direction we're going from here. We're going to be racing towards Tesla Tech of next year, man. That's my goal. I want a bunch of different systems built, a bunch of understanding between the group that we have here, all of it done before the next Tesla Tech, man. And we're going to be able to understand everything under the sun, man. So, yeah, right on. With that said, man, I want to tell everybody have a great day, man. Thank you very much for watching today. I really do appreciate it. Have a great night.
The old man built. The old man built. The old man built. The old man built. The old man builds is broken in the head. People not seeing reality has put them in the red. Where conscious and spirituality restricted from the norm and replaced with the ignorance of basic magnetic form. The geometry of God keeps running through his head. That's what makes old man builds broken in the head. The old man builds. The old man builds. Spheres of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to instead. The old man builds. The old man builds. The old man builds. The old man builds. Fears of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to extend. The old man builds. The old man builds. The old man builds. The old man builds. wheels of destiny are spinning in his mind, making him travel back and forth in time. Battling the establishment for just a little recognition, has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to extend. The old man builds